Students, so today I will start the next chapter, that is very easy chapter, redox, that is oxidation and reduction. We have the preliminary knowledge on that, and also it was on class 10, but the electronic concept I am new. Hitesh, yes. So last we have discussed on 3 chapters, that is the p block elements and the states of matter, and last of all the thermodynamic states of matter, and in the online mode we have completed the last chapter, that is on the last day. Equilibrium. Okay. So thermodynamics, equilibrium and states of matter is completed. Now Hitesh, you may have got the syllabus, and if you not, then you may download it from the CBSE website, and there is a modern version is given, which is their 30% syllabus is deducted, and you will get this notification also from the CBSE. Okay. So today it is the chapter 8, that is unit 8, redox. Okay. So redox, that is reduction plus oxidation. Now we know the different definitions on that. What are the definition? That is when we adding oxygen to any element, then it is oxidized, and when we eliminating oxygen or adding some electropositive metal, that is any metal, then it is known as reduction. Okay. So addition of oxygen or any electronegative element, or in the same time liberation of the hydrogen or any electropositive element, that is at the same time it may be addition of oxygen or any electronegative element addition, or liberation of hydrogen or any electropositive element is called as oxidation. So here in the example, C plus O2 equal to CO2, FeCl2 plus CO2, FeCl2 plus Cl2 forming FeCl3. Here chlorine is electronegative or a non-metal, so it will also called a oxidation reaction. H2S plus Br2, H2S plus Br2 forming 2,8Br plus S. What happens here? Here hydrogen is adds with bromine, that is electropositive metal will add, so it is an example of reduction. But on the another side, from H2S to sulfur, here hydrogen is eliminated, so it is also called a oxidation, because hydrogen is eliminated, that is an electropositive metal eliminated. So it was the sir from where we will get the syllabus, Oishiki. You don't know about that? Go to the CBSE website. CBSE website, there you can found in the academics, CBSE academics, you can find the syllabus. CBSE academic, you can find the syllabus. And also if you have got the books, then you will also get the syllabus, that which chapters you have to study. Hitesh and Oishiki. Okay. So in this case, here at the same time oxidation and reduction occurs, and the last class, that is in class 10, there was the oxidation and reduction occur simultaneously. So, from this example you can tell that oxidation reduction occurs simultaneously, and there was the far more example on that, that is MnO2 plus Mn plus 4HCl forming MnCl2 plus Cl2 plus H2O. This was also an example which was given on the class 10 NCERT book. It is here also the oxidation and reduction occur simultaneously. Okay. So, MnO2 and HCl. So, from this example we can again recap our previous knowledge on oxidation and reduction. Now, the modern concept is that here we have to use the concept of oxidation state. We have to use the concept of oxidation state, and we can define oxidation and reduction with the use of this oxidation state. So, oxidation, that is increase in oxidation state, increase in oxidation state, okay, and reduction, that is decrease in oxidation state. Now, the another similar term of oxidation state is the valency, but the more appropriate term will be the have you got it? More appropriate term, it will be the oxidation state, correct. So, increase in the oxidation state, that is oxidation, and decrease in the oxidation state is reduction. Now, follow one example. So, Na, sodium, when a element is in the free state, when the element is in free state, his oxidation state is taken as 0, because here sodium, it is only the elemental sodium, so its oxidation state is 0. Now, I am writing one conversion, that is Na to Na plus electron, it is the ionization equation. Here one electron will eliminate from the elemental sodium. One electron is liberated from the elemental sodium forming Na plus. Now, here change in the oxidation state 0 and its valency is equal to plus 1. So, change in the oxidation state, that is equal to 1 minus 0, that is equal to plus 1. So, here oxidation state was 0 and from that it has changed its oxidation state to plus 1. So, we can call it as an oxidation reaction. Okay. And at the same time the electron is liberated in the reaction. So, when a species liberates electron, then it is oxidized. Okay. So, in the same time we can define it by using the electronic concept, and also we can define it by using oxidation state concept. Here oxidation state is increases from 0 to plus 1, that is oxidation. At the same time the electrons also eliminated, so it is called the oxidation, that is liberation of electron. There are liberation of electron is also called oxidation, and taking up of electron is reduction. This is the concept. So, we have to take both of these, that is electronic concept and oxidation state concept. So, oxidation state and electronic concept. The electronic concept, that is the liberation or taking up of electron, and the oxidation state, that change in the oxidation state. So, increase in oxidation state, that is oxidation, and decrease in oxidation state is reduction. Okay. Suppose Cl plus electron forming Cl minus. What the reaction is? I told that the free state is 0 here. Here it is -1. So it is a decrease in oxidation state. So according to the concept, it is also called as reduction, and in the same way it takes up the electron. So we can also call this reduction. So the process is a reduction process. Now take one example, Na plus H2 forming 2NaH, 2Na plus H2. Now here it's having in 0 oxidation state, hydrogen in the free state 0, but here what happened? Sodium hydride. Here sodium is in +1 oxidation state, hydrogen is in -1 oxidation state. Okay, because both are electropositive, but sodium is more electropositive than hydrogen, so it will take the plus charge. So what is the change here? That Na forming Na plus and hydrogen produces 2H minus, 2Na plus 2 electron, it takes up the 2 electron forming 2H mass. So first one, here it is the oxidation and it is the reduction. So here we can tell that here sodium is oxidized and hydrogen is reduced. So in the same time we can show that both the oxidation and reduction occur simultaneously, right? We can also prove it by further example, that is Zn plus HCl forming ZnCl2 plus H2. Here hydrogen is in +1 oxidation state, chlorine is -1, zinc is 0, because I have told that in the free state any metal or any element having the oxidation state is equal to 0. Here chlorine is -1, so overall charge is equal to -1 into 2, that is -2. Now the overall complex is neutral in nature because there is no charge, so zinc is in +2 oxidation state. Here hydrogen is in 0, so just follow it, zinc from 0 to 1, so increase in oxidation state, that is oxidation, and here it is a decrease in the oxidation state, that is reduction. So increase in the oxidation state, zinc is oxidized to zinc chloride and HCl is reduced to hydrogen. So here we can see both oxidation and reduction occur simultaneously. Okay. Now the next term, that is what is oxidation and reduction half. Oxidation half and reduction half. Oxidation half and reduction half. Take the previous one example, Zn plus HCl forming ZnCl2 plus hydrogen. Zn plus 2HCl forming this. Okay, it was in 0, it is in +2 oxidation state, it was in 1, it is in 0 oxidation state. Now this couple, that is Zn2 plus, it is called oxidation half or oxidation couple, right? And H plus to half of H2, it is called the reduction couple. H plus to half of H2, or you can write 2H plus to hydrogen, it is called the reduction couple. This is also called reaction hub, that is oxidation hub and reduction hub, both of these combine to make the overall reaction. Have you understood? Oishiki and Hitesh. As both of you are new, but you having the concept of oxidation reduction from the class 10. Are you from CBSE or ICSE? From which board you are? ICSE. So you have a clear concept on these chapters, because these boards discuss in detail. CBSE also there was the concept. Okay. So oxidation hub and reduction hub. So you will try that H2S plus Cl2. I have already discussed it. So I am taking a new example of this, that is H2S plus Cl2, that is HCl plus S. H2S plus Cl2 forming HCl plus S. Okay. So we have to balance it, that is 2HCl plus S. Okay, it is balanced. Now we have to give the oxidation state to the element. Here hydrogen is always +1, sulfur here it is -2, because +1 that is +2 +1 into 2. Now overall that is neutral, so it will be -2. Chlorine, here you should not you have to forget about the group valency, because sulfur is it of group 16 element, but here the sulfur is as anion. Now chlorine in free state 0, here it is in +1, it is -1, it is sulfur having 0. Now follow the change in oxidation state. From here from chlorine to Cl minus, here decrease in the oxidation state, so it is called reduction. And on the another side -2, that is increase in the oxidation state, that is oxidation. Clear? So we can write the oxidation half. Yes, oxidation half. What is the oxidation half? That is S2 minus 2 S, and reduction half, that is equal to reduction, that is Cl2 to 2Cl minus. It is the reduction half. I see the light, but I think that it was the flash from mobile. Okay. So the oxidation half and reduction half is this. You may try one more example on this, that is Fe3O4 plus aluminium. Okay, I am writing down this. Fe3O4, 3 Fe3O4 plus 8 aluminium forming Al2O3 plus iron. 4 Al2O3, 9 Fe. Okay, it is in balance form. Now you have to find what is the change in oxidation state. Oxygen, here the oxygen, as it is the oxide, it having -2 valency. Aluminium, we know it is in free state, it is 0. Here iron also in 0. So the overall charge made by 4 oxygen atom, that is equal to minus 2 into 4, that is minus 8. Okay. Now the minus 3 charge is circulated by 3 iron atom. Okay. So here the iron having 3, that is minus 3, that is 24, minus 8 into 3 minus 24, 3, that is equal to plus 8 by 3, 8 by 3 plus 8 by 3. Next it is 0. Here aluminium, it is also minus 6. Now this is charged plus 3. So what is the change in the oxidation state? Minus 8 by 3 to 0, that is decrease in oxidation state, and here increase, that is oxidation and it is reduction. Fe3 plus plus I minus I2 plus 2 Fe2 plus. This is called an ionic equation. It is in plus 3, so the oxidation couple is equal to I minus, sorry, it is I2, I minus to I2, and reduction couple, that is Fe3 plus slash Fe2 plus. So it indicates that in the reaction I minus transferred to I2 and Fe3 plus transferred to Fe2 plus. It is also called oxidation or reduction couple. Here one example, that is Mg plus Cl2, Mg plus Cl2 forming MgCl2, Mg plus Cl2, that is MgCl2. Now it is in 0, 0, it is plus 2, it is minus 1. So 0 to plus 2, that is oxidation, minus 0 to minus 1, that is reduction. So the couple, that is oxidation couple, is equal to Mg, Mg2 plus, and reduction couple equal to Cl2, Cl minus. Very easy. By this way, we can predict the oxidation and reduction half to the reaction. Next one, we know the what is the activity series. The activity series, we have told earlier that in the activity series, there the ionization potential will be accounted. Now if we follow this, that is from aluminium to aluminium 3 plus, or from iron to iron 2 plus, or from I minus to iodine, there only the electron will be released from the ground state, or it will abstract the electron. Okay, so the process is also called as oxidation or reduction, right? Now according to this, that is we can arrange the metal according to the potential. There are two kinds of potential. One is reduction potential, another one is oxidation potential. Okay. So, the reduction potential and oxidation potential. What is reduction potential? That means Na to Na plus. It is called, the process is oxidation, and the energy required to transform such kind of change is called as a part of oxidation potential. But the reverse one, that is Cl plus electron forming Cl minus, 2 Cl forming 2 chlorine plus 2 electron forming 2 Cl minus. Here the process is reduction. So, here the potential is required is called the reduction potential. Okay. Now, the potential having different value, one having plus but another one is minus, but the numerical value is same. Okay. Now, you have already studied about this activity series, that lithium or potassium at the top of the activity series, and the gold, platinum, these are at least of the activity series, but it will be discussed on the basis of oxidation and reduction potential. Okay. Next one, concept of oxidation number. What is oxidation number? So, I have already told you that oxidation number is the valency. It is the oxidation state of an element. It is the oxidation state of an element in a compound according to the set of rules formulated on the basis of electrons in a covalent bonding or entirely to the more electronegative element. So, the number of covalent bond one element can form, or how many electronegative or electropositive elements attached with that element, it is the valency or oxidation state of the element. There are some rules regarding to that. I have already told you, when a metal or element in free state, its oxidation state is 0. Hydrogen having the oxidation state of 1 when it is connected with a less electropositive element, but when it is more electropositive, for example in sodium hydride or potassium hydride, as they are more electropositive than hydrogen, their hydrogen is having the valency or oxidation state equal to -1. Okay. But oxygen having the valency in the peroxide, here H2O2, here oxygen having the valency of -1, because on oxygen having in general it is in -2, but in peroxide it is different. We know it is a peroxo bond, it is different kinds of bond. So, it is a peroxo bond where the oxidation state of oxygen is equal to -1. In the superoxo compound also there, which will be discussed on the S block element, superoxo compound, here also different oxidation state of oxygen found, here it is -12. All the halides having the oxidation state of -1, that is Cl minus, Br minus, etc. And for example, CH4 and H2SO4. CH4 in neutral molecule, sum of the oxidation number of all the elements is 0. Sum of the elements of, that is in CH4. Hydrogen having +1, so +1 into 4, that is +4. So, carbon having -4 valency. In H2SO4, hydrogen +1 into 2, sulfur -2 into 4, that is 8. So, the remaining is equal to +6, that is +2, here -8, so it is +6. So, in this way, in a neutral molecule, the charge are balanced within the element. Okay. So, today I have discussed the definition of that and the concept of oxidation number. On the next day, we will start how to calculate the oxidation number of an element in a compound, and there are different kinds of oxidation state, that is fractional oxidation state and etc. And how to calculate this oxidation state, it is very important, because when we are balancing any equation, we have to take the concept of oxidation state, okay, and how to calculate the equivalent mass on a reaction. This will be discussed on the next class. Okay, students. So have you understood up to that what I have discussed today? Very good. So bye everyone. Thank you for staying with us. Meet you again on the next class with new concept. Okay. So bye bye everyone.